So that was immutable variables, or vals. Now let's do their mutable counterpart, vars. Vars are mutable, which means they can be reassigned. In 21, an ace is like a var, as it can be worth 1 or 11 points, depending on the player's choice. We write var, the variable name, aceSpades, the type, int, then equals 1. Vars are similar to non-final variables in Java, if you're familiar. You saw that since fourHearts is a val, the Scala interpreter yelled at us when we tried to reassign it. Since aceSpades is a var, reassigning it the point value of 11 works just fine. At first think, it seems like having a variable that you can't change is a terrible idea, and that we should always use vars over vals. But in Scala, we actually prefer immutable variables, vals that is, where possible. Here's a few reasons why. First, your data won't be changed accidentally, by an error in your program's logic, for example. Preferring immutability is a form of defensive coding. Second, your code is easier to reason about, since you don't have to mentally juggle all of the places where your data can change. Third, immutability means you'll have to write fewer unit tests to make sure your program works as expected. The main drawback of immutability is the extra memory generated by copying objects. Since vals can't be reassigned, to change them, you'll need to create a new object. Your programs will be a little larger. Fortunately, unless you are working with massive data structures and copying them thousands of times a second, the pros often outweigh the cons. As you'll experience throughout your Scala journey on DataCamp, Scala nudges us towards immutability. Because we are forced to copy our objects each time we want to make a change, we become much more conscious of how and when we change our program's state. With this philosophy, we receive fewer possible states within our programs, fewer defects, and code bases that are easier to maintain. We've defined vals like fourHearts and vars like aceSpades. Using a powerful feature of Scala called typeinference, we can make this code even more concise. All we need to do is drop the colon, then the type, int in this case. Scala can infer that fourHearts is an int because it knows whole numbers like 4 are typically meant to be integers. Typeinference not only applies to variables, but also collections, functions, and more. With the rule of thumb being programmers can omit almost all type information that's considered annoying. Typeinference saves keystrokes and characters, which is a big deal in massive code bases. You'll experience typeinference more in this course later. There is something else that contributes to Scala's conciseness. You may have noticed that there are no semicolons at the end of these statements. There could be, but Scala tries very hard to let us skip semicolons wherever possible. And most Scala programmers do. So we'll do that too. Now you can consider